Welcome to Seeing More of the Universe. I'm your host, Alyssa Goodman. In this very short episode, I would like to focus just on the difference between big data and wide data and emphasize the value of wide data. So, big data is a phrase that you hear all the time that has to do with the ever increasing volume of data that humans have available to them to bring to bear on questions involving everything from online shopping to the history and origins of the universe. Now, of course, in this series, we're more concerned with the universe. But in this video, I want to emphasize that even though I myself have dealt with some pretty large data sets, I find that the most insight comes from combining data sets, whether they be big or small, and looking at the interaction of various processes that are traced by different kinds of data. So here's a list, and for star formation experts, feel free to read that list. But I'll just tell you that this is a diversity of data represented in this single image. And from the image itself, not much can be learned. But from the analysis of all the different kinds of data shown here, one can understand how stars form in the interstellar medium, how long that takes, and what those stars do to the gas around them. And for the non-experts, take my word for it that you could not study those processes from one big data set alone. You actually need the context provided by all the other data sets. Here's an example from the Planck mission, which probed the entire sky at many different wavelengths. And these funny projections actually show you the whole sky unwrapped at many different wavelengths and combination of wavelengths that trace different processes having to do with the microwave background or dust in the galaxy. And you see that not only are they different colors, but again, if you're an astrophysicist, you might appreciate that these trace different physical processes, and you're actually interested in the interaction of these processes, and you need more than one kind of data set to understand that. Let me give you a more recent example from my own work. I really love this story. The extraordinarily short version of the Radcliffe wave story is that it's really, really hard to understand the structure of the Milky Way galaxy because we're buried inside of it. As I suggested, I'd really like to tell you the astrophysical details of this story, but I'm going to leave that out for now and just claim that the different kinds of information that are shown in these boxes were all absolutely critical to understanding this new geometric structure in the Milky Way. Hopefully you can understand that it's the combination of data sets, the wide data, that really were absolutely critical for this discovery. In addition, applying the concepts we learned about in the previous video about data dimensions and display, and using this handy glue software that allows for the linking of views in different panels that you see here, were also really important for the discovery. The same thing is true in many other instances. Here's an example of a study of Orion, where you have infrared imagery at many colors. You again have many different kinds of molecular line maps and different stellar catalogs. And it's just one of many examples I could give you about how these three concepts of data diversity, data dimensions and display, and linking views of data are absolutely critical for understanding. Those of you who've watched our video about going back and forth from exploration to explanation may recognize that glue screenshot as part of this broader story about how the output of really good exploratory data visualization software can also produce explanatory visualizations. Hopefully you're starting to see how all of these concepts featured in our series connect. Our final video will be about the importance of linked view data visualization, so please stay tuned.